I'd like us to talk about these three things today. We say every system of linear equations has zero or no solution, one or unique, or infinitely many solutions. Now, let's quickly look at the following few examples before we work on our exercises. Here, let's look at this system of equations. X minus y equals to 1, 2x plus y equals to 6. Then, when we solve this system, we do the very same thing as we did. We write the system in matrix form, then that means in matrix form, our matrix will be 1, -1, 1 in the first row. Do we agree? Do we agree? Oh, let me say, do we still agree? What we are saying this system of equations x minus y equals to 1, 2x plus y equals to 6. We'll write it in matrix form, and then in the first row we'll have 1 minus 1 and 1. In the second row we'll have 2, 1 and 6. Then in order to solve this system, then we'll have to create a 0 where there is a 2 in the second row. Then by backward substitution, we'll be able to get the value of x and the value of y after doing that. Then, by doing that, then we'll only get one solution, which in this case, x is equals to 7/3. And then when we take that value of y, in this case, when we do that, the first thing that we'll get the y value to be 4/3. When we take that value of y and substitute it in the first row, we'll get our x value to be 7/3. Now, in this case, our solution will just be 1, where our x will just be 7/3 and our y value will be 4/3. That is what I'm trying to say in simple terms. Then, that holds for all systems when we are determining whether a system has got one solution or many or no solution. Now, in this next example, in this system, x plus y, which equals to 4, 3x plus 3y equals to 6. Now, we do the very same thing. We write this system in matrix form, where there is 3 below, where there is, okay, let me say, this is x plus y equals to 4. Let me rephrase what I just said. This system is x plus y equals to 4. 3x plus 3y equals to 6. When we write this system of equations in matrix form, then we will have 1, 1, 4 in the first row. In the second row, we will have 3, 3, 6. Then we will have to solve this system. How will we solve that system? Where there is a 3, the first 3 in the second row, we will have to have a 0. Once we have got a 0 there, then we will be able to get the y value. After getting the y value, then we will be able to substitute in the first, in the second, in the third, in the fourth, in the fifth, in the sixth, in the seventh, in the eighth, in the ninth, in the 10th, in the 11th, in the 12th, in the 13th, in the 14th, in the 15th, in the 16th, in the 17th, in the 18th, in the 19th, in the 20th, in the 21st, in the 22nd, in the 23rd, in the 24th, in the 25th, in the 26th, in the 27th, in the 28th, in the 29th, in the 30th, in the 31st, in the 32nd, in the 33rd, in the 34th, in the 35th, in the 36th, in the 37th, in the 38th, in the 39th, in the 40th, in the 41st, in the 42nd, in the 43rd, in the 44th, in the 45th, in the 46th, in the 47th, in the 48th, in the 49th, in the 50th, in the 51st, in the 52nd, in the 53rd, in the 54th, in the 55th, in the 56th, in the 57 row for y to get the x value. Now, let's look at how this system then becomes interesting while trying to solve it. In this first example, when it was solved, it was found that y was equals to 4/3. But now look in this case. In the process of solving this, in the second row, in the place, that means in the place of y, x is 0 and then y is 0, but on the right hand side we have got -6. So in this case we are saying we have got 0x. We're also having 0y, which is equals to -6. That's why we are saying this system has no solution, because we cannot have 0x, 0y equals to a number. Is this making sense to you in terms of why we are saying this system has no solution?
Yes, sir.
Yes, sir. Yes, sir.
Thank you. If it does, now let's look at this other example where we've got this system 4x minus 2y equals to 1 and 16x minus 8y equals to 4. Then writing this system of equations in matrix form, we end up in the second row with an entire row of zeros. I did indicate to say if you solve a system of equations and then you end up having an entire row of zeros, that shows that that system has got infinitely many solutions. Any question on these three examples that we just talked about? Because what we are going to do in the next remaining minutes will be revolving around these three examples that we just spoke about.
So I have a question. Remember, I asked you with regards to the many solution, no solution, and I'm not sure if I'm late or still early, because I just got here when you explained the no solution values, or rather the equation. So, okay, and the infinitely many solutions. I'm not sure if I missed the first one.
Musa,
Yes, sir. Yes, sir.
is it you?
Yes, it's me, sir.
Yes, what were you saying, my brother?
I was asking that I just got here, and you, what I understood is when you were explaining the no solution equation. So I'm not sure if I missed the infinitely many, or maybe if there's another type of solution that is involved on matrices that I missed. I just wanted to make sure if I'm not lost.
My brother, you are not lost, and
Okay.
then you didn't miss a thing because we just started.
All right. Thank you.
We've been dealing with matrices since we started,
Okay.
but now I need us to deal with these three at once to make sure to test your understanding, because we spent is it last week or the past few weeks
Yes,
on
sir.
systems of equations, but now I want to bring them at once. At this point in time, almost all of you are able to solve system of equations. Am I wrong to say that?
No, you are right, sir.
No, sir.
So all of us can be given any system of equations, we can all be able to solve them. Now, what I need us to do is to can be able to tell given a system of equation, the conditions, if we are given a system of equations, when they say to us, when they ask us, when will a particular system of equations have infinitely many solutions? Let's start with the first one. When the system will have one solution or unique solution. Next, when that system will have no solutions. Next, when it will have infinitely many solutions. 3 in 1. When will the system have one solution, meaning unique solution? When will that system have no solution? When will that system have infinitely many solutions? Now, any question before I proceed?
Yes, sir, I have a question.
Let me come here. Yes. So, who's having a question?
It's me, sir.
Who? Oh, Princess.
Princess.
Yes.
Yeah.
Mm-hmm.
Yeah. So, sir, like, if we have like a matrix that has like, rows of zeros, and also like, and the other row is also filled with zeros, but it equals to like -6. Like we have a situation between infinitely many solutions and also, I think, one solution. What type of matrix is that?
Princess,
Yes, sir.
please don't confuse me. Slowly, come up slowly with your question, because I picked up two things in your question, but now I need to make sure that I picked up the correct thing that you talked about.
Yes.
Slowly,
So what I'm basically saying is that, like, with the system, what type of system would it be if like we have rows filled with zeros, and then the next row is like it's also filled with zeros, but the it's 0x0000 and then a -2. But there's like one row filled with zeros, and then there's one row that equals like -2, like 0 equals to -2. What type of solution? What type of system would that be?
Okay.
Sir,
Yes.
can I attempt to answer Princess's question?
Yes, sure.
So what Princess says that there's a row full of zeros, which means infinitely many solutions. And then there's a row full of zeros, which is equal to -2, which means no solutions. So since there's a row of no solutions, infinite solutions are a solution. Therefore, like that row has no solutions overall, like the matrix, not the row. That's what I think.
Princess.
Yes, sir.
They usually say someone's question is loaded. In this case, allow me to say your question is loaded. The reason being that when we solve a system of equations,
Yes.
if we have got an entire row of zeros in the process of solving, then we conclude by saying what? By saying that matrix has got infinitely many solutions. Okay?
Yes, sir.
Are we together on that one?
Yes.
But now you went a step further and said there will be 0, 0, 0, 0, 0, then a number on the right hand side. That's what you said, no?
Yes, sir.
Yes. Now, if you've got that situation, if you have got that kind of a row, 0, 0, 0, 0 for all the variables and then a number on the right-hand side. We say that matrix has no solution. That's why I'm saying your question is loaded. It has got two aspects on it. So now, in this case, which one do we consider first, Princess?
Okay, if you get the like, if you, I don't know, but I'm going to conclude it by saying like, if your next step is you got a full row of zeros, maybe the answer is infinitely many solutions.
Yes. Okay. Let's do this. You and I. We are solving this system, then we end up having an entire row of zeros. We immediately conclude that this system has got infinitely many solutions. Okay?
Yes.
Now, it's you and I again. We solve this system. In the process of solving this system, we have got 0, 0, 0 for all those variables, but on the right-hand side, we end up having a number. Okay?
Yes.
In that case, then we immediately conclude to say this system has no solution. Now, the tricky about your question, I don't know which one would have came first. Whether an entire row of zeros or the zeros for all the variables and then a number on the right-hand side, or what? And then
okay.
you can never have those two in one matrix.
Okay, so the correct answer will be the one that comes first.
Yes.
The voicemail right
Thank you, sir.
Thank you.
748. MTN will to this number.
MTN.
Goodbye.
Hey, Matsoso. I'm listening, brother.
So my question was in relation to that row of zeros. And I mean, if I remember well, you said that we can swap rows before we start operating on any of our variables or our rows. So now under what circumstances or what is it that should you look for you to be able to swap the rows before you start with your row operations?
What, if I understand you correctly, you are asking me what is it that one needs to look for before one can swap the rows before starting to solve a system of equations?
Yes, sir.
Okay. How do we solve a system of equations? We solve a system of equations by trying as hard as we can to make our leading coefficient to be 1 and creating zeros below the leading 1 and zeros below those other ones that will lead in the process of solving. If we realize that, let me give you a typical example. Let's say you have been given a system of equations, né?
Yes, sir.
And then somehow you realize that in the second row, the second entry is a 0. Let's say in the second row, the first entry is a number, but the second entry is a 0. Regardless of what let's say it's a 3 by 3 matrix, regardless of what the third entry is, okay? In that case, one can swap column 1 and column 2.
So
If,
we can do that
if
before we start.
only before you start. And that can only be done, only, hear me out clearly. You can only do that only if below the leading 1. Okay, let me rephrase my statement. That can only be done if that process of swapping will lead us to have a 0 below the leading 1. I don't know whether you follow me or what.
So if I'm to understand you correctly, okay, we'll definitely do our entries. Before we start operating on the matrix, we check to say maybe what is that leading value. And if that leading value is 1, if I'm hearing you correct, I mean the second entry of maybe that second row is having a leading value of 1 and maybe the next entry of 0, then it's only then we can swap before we start working on that matrix.
That's what I'm saying, yes.
Okay,
because
thank you, sir.
the whole idea of swapping rows and columns is to try to minimize the process of getting those zeros below the leading 1. That is the only reason.
All right, understood. Thank you, sir.
Thank you. Are we
Sir.
all clear? Yes.
It's Usiso, sir. My research, sir, from our last conversation, I researched about the swapping of the rows, and my research says I can swap rows while solving the matrix.
While solving the matrix?
Yes, sir.
Yeah, that's your research.
Yeah.
So that means in the process of solving matrices, then you can be swapping rows and columns.
No, sir, only rows, not columns. I researched that and I proved it, sir. I tried the matrix and it didn't change the solution.
This is what we are saying. We are not only swapping rows. You can swap rows, you can also swap columns. But that can only be done at the beginning, not beyond. But I'm not disputing your research. That is your research. But according to my research, you can only exchange rows and columns only at the beginning, not during the process of solving matrices. Are we together?
Understood.
Thank you.
Yes.
Thank you. Can I proceed now? Now, please write down this system of equations. Are you ready? Are we all ready? Okay. In the first row, please write x minus 2y plus 3z equals to 4. X minus 2y plus 3z equals to 4. That's our first row. All got it? Our second row, 2x
Wait,
minus
this row.
first row,
Yes, sir.
x. First row, x minus 2y plus 3z equals to 4.
I got it, sir.
Can I continue this
Second
to
row,
the
sir.
second row? Second row is
Yes.
2x minus 3y plus a, letter A, z equals to 5. Got it?
Yes, sir.
2x minus 3y plus letter A, letter z. 2x minus 3y plus az equals to 5. That's the second row. The third row is 3x minus 4y plus 5z equals to b. Letter B. 3x minus 4y plus 5z equals to b. Roman figure 1. For which values of A and B does the system have Roman figure 1, no solution? Roman figure 2, a unique solution? Roman figure 3, infinitely many solutions. For which values of A and B does the system have Roman figure 1, no solution? Roman figure 2, a unique solution? Roman figure 3, infinitely many solutions. I'll give you 3 to 4 minutes to work it out. But let me request you in this way. We'll do it one by one. When you are done, I'm not expecting you to get answers for Roman figure 1, 2, and 3 at the same time. Once you get your answer for Roman figure 1, this is what we're saying. That 3 to 4 minutes that I'm referring to is for getting an answer for Roman figure 1. Then we talk about it before we go to Roman figure 2. Am I clear? For your question?
Did you already give out the questions?
Oh, yes.
But I cannot see them on my side.
I agree with you. Here is the question, my brother. It is not on the screen. I didn't project it. I read it out. Everybody, are you ready to take it down?
Yes, sir.
Here is how the question goes. For which values of A and B does the system have Roman figure 1, no solution? Roman figure 2, a unique solution? Roman figure 3, infinitely many solutions. Have you got that?
Yes, sir.
Now, here is the system. The first row for the system is x minus 2y plus 3z.
X
minus 2y.
Yes, sir.
Plus 3z
Yes, sir.
equals to 4.
Equals to 4. And the second one?
Second row.
Yes, sir.
2x minus 3y.
2x minus 3y.
plus AZ, letter A and letter Z equals to 5.
A plus AZ
Yes, plus AZ equals to 5.
equals to 5. Okay, sir.
The last row is 3x
3x
minus 4y plus
Yes.
5z equals to letter B.
5z equals to letter B. Okay, thank you, sir.
We are only solve it, and then we are all. You'll only solve it up to only Roman figure 1. You solve the system, then if you are ready with the answer for Roman figure 1, the condition for Roman figure 1 is then that you'll say you are ready, then we talk about it before we continue to Roman figure 2.
Okay, sir.
This applies to everybody. Spusiso, what are the conditions for the system to have no solution?
Sir, firstly, my A must be equals to 4. Sir,
A must, I'm listening. Your
and
A
my
must be
B
equal to
4.
your A must be 4.
Yes, sir.
And then B
Must be greater than 18.
why greater than 8? Why must B be greater than 18, if I may ask?
So when I was solving my system of linear equations,
Mm-hmm.
on my last row,
Mm-hmm.
I have 0, 0, negative 2a plus 8, and negative 18 plus b. So if b is equals to 18, it means that my solution will have infinitely many solutions if my b is 0, sir. But if my b is greater than 0, it means that I'll have 0, 0, 0, and 0. And where there is b, if b is greater than 18, I'll have a number that's greater than 0.
I hear you. Let's go back to your last row. What did you get? 0, 0.
Negative 2a plus 8.
Mm-hmm.
Negative 18 plus b.
I seem to agree with minus 2a plus 8. No?
Yes, sir.
I don't know whether it's me or you who made a mistake on this last entry, the one that has got a B. Would you please double check?
Okay, so can I ask, what's your row 2?
My row 2.
Yes, sir.
0, 1, A minus 6, minus 3.
Minus 3, sir. Okay, I must check. I got positive 3. I'll check.
Lerato, what did you get as your last row?
My last row, it's 0, 0, minus 2a minus 8.
0, 0, minus 2a minus 8. And then last entry?
B plus 18.
B
Plus 18.
Okay, hang on. Sbusiso, Princess, I will be with you. Sbusiso?
Yes, sir.
Lerato, please listen to what Sbusiso is going to say. Ne?
Yes, sir.
Okay. Sbusiso, your last row is 0, 0, minus 2a plus 8. Ne?
8, yes, sir. And
Plus-
B plus 6 minus 6. Now B minus
B,
B minus 12.
now you're confusing me.
No, sir. So sorry, can I fix my equation first, sir? It's
Please
B
fix your,
minus
okay.
6. Yeah, B minus 6.
We are giving you 30 seconds to double check your row. We are waiting.
Yeah, I'm sure. So it's B minus 6, sir.
Sbusiso, Lerato, please listen carefully. Sbusiso, what is your last row?
It's 0, 0, negative 2a plus 8, and B minus 6.
Thank you. Lerato, what did you get? That's your last row.
It's 0, 0, negative 2, negative 8, B plus 22.
Please repeat that, Lerato.
0, 0, negative, negative 8,
Lerato, 0, 0. I got that one. Yes. Third entry.
negative 2, negative 8.
Negative 2, negative 8.
Yeah.
Which is negative 10, isn't it?
No, like negative 2a.
Oh, negative 2, or negative 2a and then?
Plus 8.
Negative 2a plus 8.
And then B plus 22.
Sbusiso? Okay,
Yes,
Lerato? Okay. I heard you, Lerato. Someone is Princess, your hand was up.
Yeah, I wanted to say I'm also done too.
What is your last row?
It's 0, 0, 8 minus 2a and b minus 6.
Thank you. I heard you. Lerato.
Sir?
Please double check your last entry.
Yeah, like I'm doing it again since you said it's wrong. So
I never said that.
yeah, I'll double check.
I agree with all the entries that you said, ne?
Yes.
But I'm not comfortable with your last entry.
Okay, I'll double check, sir.
And I'm not saying it's wrong. I'm just saying, please double check it.
Okay, I will.
Up to so far, Princess and Sbusiso have got the same answer. And then even the last entry is similar for both of them. Hey, Matsuso, what did you get?
I got the same matrix as Busiso and Princess.
Are you sure?
Yes, sir.
Okay. Lerato, we are giving you a minute to double check your last row before we can start to talk.
Okay.
Menier,
Yes, Manier. Who's talking?
it's Matus.
Matsu. Hey, Matsuso. Yes, I hear you, brother.
So just to confirm, while we're waiting for, is it Busiso Rato to finish off? So the second row, okay, the second row entry, this is what I got, 0, 1, a minus 6, and negative 3.
Is that
I'm
what
not
you
sure.
got?
Yes, I'm not sure if it corresponds with the other two as well. That's my second row, but the third row is the same.
Whoa. So that is also my second row. What you just said is also my second row. Then you can ask them.
Sir,
Hang on, Lerato. Matsoso, please talk to Sibusiso and Princess about the second row. Please ask them whether they've got the same thing with you or not.
All right.
Yeah,
This is when
but
you guys get the same stuff.
yeah, for the second row, yeah, I did.
Okay, Princess is agreeing. I'm not sure about if it's Busiso.
Sibusiso, do you agree or disagree?
I agree, sir.
Okay, thank you. Then Lerato.
I'm not sure still. Is like the last row one.
And the last row is?
It's 0, 0. 2A plus 8. B.
Lerato, what's wrong?
Oh,
Can someone help out? Can someone help Lerato out?
Say the second
Yeah.
row, your second row or everyone's second row is 0, -1, 1 minus 6, and 3.
My second row is 0, 1.
Okay, that's the problem.
A minus 6 minus 3.
Okay. -3. Okay. Yeah, I see. Yeah. Is it -2A plus 8?
Are you now on the third row?
Yes, like 0, 0, -2A plus 8, B minus 18.
B minus?
18.
No.
Oh,
Minus 6.
-6. Okay.
How do you get the minus 18?
I said on the third row and
Yeah, on the third.
on the second row, I multiplied the second row by -2. So it's -2 times -3, which is 6. Oh, 6 plus -12 is -6. Yeah, I see it now. Yeah.
What is your last entry then in the third row?
It's B minus 6.
Okay. Now
Guys.
there seems to be an agreement. Everything, all those 3 questions, we are now in a position to can be able to answer them. Do we agree? Sbusiso,
Yes.
Princess,
I agree.
Lerato,
Yes.
do we agree?
Yes, sir.
Okay. We are all in agreement in terms of our answer. No.
The matrix.
We are in agreement in terms of what we get as our
matrix.
Second and third row. Okay. But the most important thing to remember is that that last row is the one that is going to guide us, or that is going to give us all the answers that we need. An answer to Roman figure 1, to Roman figure 2, and to Roman figure 3. Do we agree on that?
I agree.
Now, all of us, let's now look at our third row. Remember those first three examples that we looked at the beginning of this workshop? Here are the three. One solution, meaning unique solution. Okay, now we are saying one solution is unique solution. We agreed, ne?
Yes.
Yes, we agreed. Now, no solution. We agreed. This is the condition that we need to satisfy. Meaning the system must, any solution that we are solving must satisfy this condition. And then finally, infinitely many solution, that system must satisfy this condition. This is the condition that we are looking for. In no solution, this is the condition that we are looking for. Are we clear?
Yes, sir.
Yes, sir.
Now, if we're all clear, now let's go to our system that we just solved. Now we look at the last row of our matrix. We say we agree that in the last row we've got 0, 0, minus 2a plus 8b minus 6. All right.
Yes, sir.
And then we say, let me double check again. We read that condition where this system will have no solution, meaning all the unknowns will be zeros. Now, what are the conditions that will make this system to have no solution with a focus on the third row? Because that's where everything is revolving around. Princess.
A would need to be 4, and B must not equal 6.
Done.
Please repeat that again, Princess.
A needs to be 4, and B must not equal 6.
A must be 4, yeah?
And B
If
must
A-
not equal 6.
B must not be 6. If A is 4, that means we will have minus 8 plus 8, that will be 0. And therefore this B must not be equals to 6. Do we all agree?
Yes, sir.
Are we all in agreement? If we agree,
I am,
then
sir.
thank you, Princess. I agree with what you just said, and everybody seems to agree with what you just said. Now, Noma Ahmed.
No, sir. Yes, sir. It's okay, sir. I understand now.
Are you
I
sure?
got it. Yes, I got it. Thank you.
Now, let's look at Roman figure number 2. Roman figure 2, a unique solution. When will this system have a unique solution? Meaning one solution. We go back to that last row of ours. Anyone?
Okay.
Sir.
Someone is talking?
Lerato can continue, sir.
Lerato, then followed by Sibusiso. Yes?
Like for my answers, I got A is equal to 7/2 and B is equal to +7.
Again, Lerato?
A, it's +7/2. B, it's +7.
I'm not saying anything. Sibusiso?
Sir, A cannot be 4. And B can be any real number, sir.
A can
Not equal 4.
A cannot be 4.
Yes, sir. And B can be any real number, sir.
Princess, what are you saying?
Sorry, sir. The network was a problem. I missed the question. What was the question?
From the third row, eh? We all agreed on the third row, eh?
Yes.
Now, when will this system have a unique solution? Hey, Lerato, what are you saying?
A must equal to 7/2 positive. B must equal to 7. That's what I'm saying.
Sure. Yeah.
I agree with Spusiso. What Spusiso said, so it makes a lot of sense. I agree with Spusiso.
Is that A must also?
Yes, I
A
agree
must
with
be
what.
4.
Yes, so A cannot be 4 and B can be any real number.
Okay, now let's do this. We are saying A must not be 4, meaning A can be any number, okay? Any number that will not make minus 2A plus 8 to be 0. Do we agree? And then B can be any real number in such a way that this B minus 6 will be any real number. Do we agree?
Yes, sir.
Lerato,
Sir,
do you see what we are trying to say here?
I understand what you're trying to say.
Are you sure?
I'm sure.
In other words, here, Lerato, minus 2A plus 8 can be anything, any number that will go with A. After the equal sign, that's why we are saying that B must be any number. Obvious. We are listening. Yes.
Can you hear me?
Can hardly hear you.
Can you hear me now?
Yeah, I can hear you.
All right, sir. I've been trying to follow you. Unfortunately I joined late, but I'm just listening to numbers, and I don't know if you can assist which problem you're tackling in the team.
Now you are fading away.
No, I was saying I'm only listening to numbers that you're sharing, but I recently joined. It's fine if you can maybe share the problem, and then I can also join the team. Because on my screen, I'm only seeing the team members.
You are right. I'm also seeing the team members because I told that I've given them this exercise to write down and then solve it.
Okay.
It is correct and it's true that you are seeing the team members. That is what you are supposed to be seeing at this point in time.
Okay, sir.
Yes. Lerato, your hand is up.
So I understand why you're saying A can be any number except 4, because A will be equal to 0 and we don't want that. But say, when we are solving a matrix, we must have leading ones originally. Do you like understand what I'm trying to say? Or
Finish your statement, then I'll be able to tell whether I understand or not. Because now it looks like you are just halfway. Your question.
The question that you gave us, you said we must solve this matrix to find the values of A and B, which fit into specific conditions which you gave us. In this condition, you said A can be any number, even 7/2, which I gave, it's A, it's any number, okay? But then, I don't know if because you said you must solve the matrix, I thought you were saying negative 2A plus 8 must be equal to 1. That's why I ended up solving for A. Like, do you get where I'm coming from? So I don't want to repeat that mistake where I solve for A to find the value of A so that I can make this whole sum a leading one. So I'm asking, like, how do you know? You just write the conditions or you find a specific value of A or B?
Okay, my brother. Maybe this will help. If what I'm going to say doesn't help, I'll ask Sbusiso and then even Princess or any other member to come on board. Lerato? Lerato?
I'm listening.
Okay, brother. Do you see that minus 2A plus 8?
I see.
Okay. When we divide the entire third row by minus 2A plus 8, the entire row, what will we be left with where there is minus 2A plus 8?
A 1.
A 1, ne? What will be on the other side?
It will be B minus 6 divided by minus 2A plus 8 equals 1.
You and I agree.
Yes.
That is the condition.
Okay.
That is the condition that, in this case, that is the condition that we are looking for. That condition will make this system to have a unique solution.
Okay.
Have I helped you?
Yes, you have helped me.
Thank you. If we agree, then can we move on to look at the last condition? The last condition where this system will have infinitely many solutions. Let me look for someone who has never even said a word in this workshop. Vuyo.
Yes, sir.
Vuyo.
Yes, sir.
Yes. When will this system have infinitely many solutions?
It will have infinitely many solutions when A equals 4 and B equals 6.
Please ask them, Vuyo, whether they agree with what you just said or not.
Hi, everyone. Do you agree with me in whatever I've just said?
Yes, I
Yeah.
agree.
I also agree.
Okay, thank you. They do, sir.
Thank
They
you.
do agree. Okay, thank you.
Thank you. Thank you, Vuyo. Now, in summary, to just sum up what I've shared with you today, in one matrix, you solve a matrix. From solving the matrix, then you can be able to explain or determine the conditions for the three conditions. No solution, unique solution, and infinitely many solutions. The most important thing is to can be able to identify when the system will have no solution, many solution, or unique solution. Is it clear to everybody?
Yes, sir.
Yes, yes, sir.
Can we proceed?
Yes, sir, we can.
Okay, thank you. Now, looking for a simple one before I step off this one. Very, very simple. Please write down the following system of equations. 2x plus y plus 2z equals to 1. Have you got it? That's the first row. First row. 2x plus y plus 2z equals to 1. In the second row, it's 2x plus 2y plus z equals to 0. Have you got that?
Yes, sir.
Do you all have it?
Yes, sir.
Okay. My question is simple and straightforward. Please find the reduced row echelon form for this system. Please find the reduced row echelon form for this system. Spusiso, what did you get?
Same. My last matrix is 1, 3/2, 0, -1/2. And my last row is 0, 1, -1, and -1.
Please repeat, brother.
My first row, sir, it's 1, 3/2, 0, and -1/2.
Thank you. Then, Princess.
So my first row is 1, 1 over 2, 1, and 1 over 2. And my second row is 0, 1, -1, and -1.
Sibusiso, please, Princess, I'll ask you to repeat. Sibusiso, please listen carefully.
Yes, sir.
I've noted your hand. I've noted your hand. Lerato will be with you. Please go ahead, Princess.
My first row is 1, 1 over 2, 1, 1 over 2. My second row is 0, 1, -1, and -1.
Sibusiso,
Yes, sir.
is that what you got? Is that what you got?
No, sir. That's the matrix before my last matrix.
And I'm not saying you should get what she got. Get me clearly.
Yes, sir.
Yes. That is not what I'm saying. So I'm just trying to establish any similarities between what Princess got and also what you got.
Second,
Lerato and Obvious, I've noted your hands. Yes, Sibusiso, before I go to Vuyo.
okay, sir. My last row, my last matrix.
Your last matrix. That's where our focus should be.
Yes,
our
sir.
focus should be on our last matrix. Yes.
Okay, sir. My last matrix is 1, 3 over 2, 0, and -2 over 1. And my second row is 0, 1, -1, and -1.
Vuyo?
Yes, sir.
Yes, please go ahead.
I get 1. In my first row, I get 1, 3 over 2, 0, and -1 over 2. And my second row, I get 0, 1, -1, and -1.
Yeah.
Princess and Sibusiso, please listen to what Vuyo has just said. Is there any similarity? For the last time, Vuyo, please just say what you got.
First row, 1, 3 over 2, 0, and -1. Second row is 0, 1, -1, and -1.
Sibusiso and Princess?
Yes, sir.
Yes, sir.
You did hear what Vuyo said. Is there any similarity?
Yeah,
Yes, no?
my second row is the same as his, but the first one, it's not the same.
Sir, my first row is the same as is, but my last column is not -1, it's -1 over 2. And my last row is the same as is.
Okay. Lerato, I'll come back to the three of you. Lerato and who else hand was up? Lerato followed by Musa.
Sir, what did you say we must find? No, sir.
Lerato, man. Lerato. Hey.
Sir.
I requested you to find the reduced row echelon form for that system of equation that I've just given you.
But the answers, they are not in reduced row though.
I agree.
So
I agree. Lerato?
Like you said, must find reduced row echelon form, Akere.
Yes.
Can't take your numbers 0, 1, 0, 1.
Sorry?
The answers they are giving are not in reduced row echelon form. They are in row echelon form.
I agree with you. I agree. Yes.
What?
I'm looking for the reduced row echelon form for the system that I've given.
Eish.
And then what they've given, it is not in the required form. Have you got the reduced? Have you got?
I got stuck,
Why now?
like everyone.
Now I'm disappointed, my brother. Okay, now let me hear what Obvious is saying. Obvious?
Okay, can you hear me?
Yes.
Hello, can you hear me?
Yes.
Okay, I just want to give you my answer. I got my first row. I got 1, 0, 3/2, and 1, and then my last row I got 0, 1, -1, and -1. Yeah.
Thank you, Obvious. Musa?
Say. Eish.
Yes.
Say now I got. Say I'm confused now. With this reduced row. Because I thought it's the echelon form. Say. Because I can see there's 1, then there's 0 there. So I don't know. Now I'm confused. Okay, my first row is 1/2, 1/2. Then my last row is 0, 1, -1, -1.
Lerado.
Say,
Oh, thank you, Musa. Lerado.
say,
You remember in our first workshop?
yeah, 2 weeks back.
Yeah. Whether it's last week or 2 weeks back, but let me remind you to say, you reminded us, you, specifically you, reminded us about how reduced row echelon form looks like. Do you still remember?
I remember, say.
Yes. I did not forget that it is you who reminded us how reduced row echelon form looks like. Please just tell everybody how a matrix in reduced row echelon form should be like.
A matrix in reduced row echelon form should have zeros and diagonal ones only.
Thank you, Lerato. And I agree with you to say whatever that Stanley, I've noted you, I'll be with you. I agree with you, Lerato, to say what has been given to us at this point in time is not in reduced row echelon form. You and I agree about that, eh?
Yes, sir.
Thank you. Stanley. Stanley.
Hello? Hello?
Oh, yes, Amos also.
I just wanted to add on that description of reduced row echelon form. Okay, it can happen that, okay, I just wanted to add, what I didn't want to say. Okay, to add on the description that for every leading one, there should be a 0 above and below, and also the following leading one should be on the right of the above leading one. I don't know if it may.
Sorry?
Or was I not audible?
No, I didn't get that.
Oh, I was adding that on reduced row echelon form, that every leading one should have a 0 below and above it, and then for every leading one on the below and on the below leading one should be on the right of the other leading one, should be on the right side of the leading one. I don't know
My
if I'm
brother.
making sense.
My brother,
Hello?
can you hear me?
Yes, I can hear you.
You are making a perfect sense.
Okay.
Perfect sense, and that's what should happen.
Yes.
Vuyo. Thank you, Matsuso. Vuyo.
Yes, sir. I guess by saying that we must give it in reduced row echelon form, I guess that we must not also include what the equation equals, isn't it?
That's not what I said. That is not what I said, my brother.
All right, sir.
No. What? I will disown you. If we go in another forum and then you say that I'm going to disown you, because that is not what we said. Okay. Now, what I got, I don't know what others got, but what I got, oh, okay, before I say, I ask what others got. Lerado, what did you
Sir?
get? Did you have this system in reduced row echelon form?
I got both the solutions from the other two people.
Hey, it's painful. I'm laughing, but it's painful.
But
I got. Sorry?
I agree with the one for 1, 0, 1.5, 1, and 0, 1, -1, -1.
Okay. Now, this is what I got. In the first row, I've got 1, 0, 0, 1. In the second row, I've got 0, 1, 2, 2. That's what I got. Now,
Sir,
while, yes.
sorry to cut you short. Can I just quickly confirm something? Because I think the problem here that we are having is that we are trying to compare our matrices together. I mean, to compare our matrices, and I don't think it's necessarily going to be the same based on the mere fact that we might have all performed our own different operations on them. However, it's the form that counts. Adding to also what Stanley has said, as long as you have it in that format, irrespective of what values you get, as long as it's in that same format that Stanley spoke about, then it should be correct. I don't think in this case we'll have the same matrix. I don't know, you'll correct me if I'm wrong.
You are quite right. You are quite right. I agree with you. Now, please write down the following matrix. Are you ready?
Yes, sir.
In the first row, in this matrix is 0, 0, 0. Are you done? In
Yes,
the second row, is 2, 4, 0. That's it. That's how the matrix is.
So I have one question.
You have one question.
Yes, sir.
Please don't raise your question before I raise my question. I've just given you a matrix. Let me first raise my question, then you can come up with your question.
Okay, sir.
Because because now mine is hanging.
Okay, sir. I'll wait.
Oh, okay. My request is that you write the matrix that I've just given you in reduced row echelon form. Now you can come with your question.
So my question is this matrix an augmented matrix, sir?
An augmented
Matrix.
Please explain what you are saying to let's avoid to term one another. I know that word augmented matrix. But now in this case, in your sense, what are you saying? I need because I did indicate to someone to say I'm staying under bridge alongside one of the freeways. It's here in Gauteng. And then I requested you to use very simple language when you talk to me so that I can be able to understand.
Okay.
Do you still remember the conversation? Do you still remember my request?
Yes, sir.
Yes, even now it is. See how the weather is today. It is raining here, and there is just a river under this bridge. It's very cold. So when you talk to me, please use very simple language so that I can understand. Otherwise, you'll make me to want to drown in this river, and I still want to live. Yes.
I'm saying, sir.
Yes.
I'm taking this matrix in terms of equations, sir.
Yes.
So is 0, 0, 0 in terms of equations being 0, 0 is equals to 0 and 2.
I've given you the matrix 0, 0, 0 in the first row. In the second row is 2, 4, 0. Then my question is, please write this matrix in reduced row echelon form. And this should not even take you 30 seconds.
Long done, sir. I don't know about others.
Long done. Yes, Mr. Mazuso, please tell us what you got.
Well, for my matrix in reduced echelon form, I got it as first row 1, 2, 0, and then second row is 0, 0, 0.
Thank you, my brother.
Sir,
yes.
My first row.
Yes, let me.
It's 2, 1, 0, and then second row is 0, 0, 0.
Karado, what are you saying?
First row is 2, 1, 0, and the second row is 0, 0, 0.
How did you come up with the 2, my brother?
I got his matrix first, the one for 1, 2, 0, 0, 0, 0. And then I forced the leading one, like I always do.
Hey, Mazoso, please explain to him how you got that one.
Sir, can you kindly repeat your question, please?
I'm requesting you to explain to Larato how you ended up having in the first row. There is no problem with the second row.
Okay.
Please just explain in simple terms how you ended up having 1, 2, 0 in the first row.
Remember, we always need to have a leading value of 1. So that 2, you are supposed to multiply the first row by half, turning that 2 into 1.
I understand.
Are you sure about it?
You know what confused me?
I don't know.
I got what he got, Ane. So I thought like the second equation. Since yeah, I understand.
And I don't want you to be confused in my presence.
Okay. I see where the problem was. Yeah, say. Like the first row, initially the row for 240 was the second equation. So I thought the 4 had to be turned into a 1. But I forgot that above there are only zeros. Therefore, we only need to turn the 2 into a 1. And then we are done.
Can you see it now?
Yeah, I can see it. I can see it.
Thank you, brother. Musa, your hand is up.
Yes, Ish. Okay, so my question is that for the reduced row column form, we need to have those zeros there on the last row. Is that what we are fighting for in that leading one there?
Your question again? Straight to the point, Musa. Straight to the point.
Yes, sir, for the row column form, say, for the reduced row column form. So we have to fight to get those zeros there on the last row. Because I'm asking this question with regards to the last equation that you gave us. Because some of us, we got like 1, 0, 1. On the last row, sorry, we got 0, 1, -1, and -1. But I heard you saying that one, it was incorrect. Was it because of the ones there or what, sir?
I don't remember myself saying it wasn't correct.
Yes, sir, because we didn't get the answer for that one, to be honest, sir. So I'm still stuck.
I said,
yes,
someone said, because we solved differently,
yes,
we
sir.
will not have the same answers. Then
Yes.
I said, yes, I do agree.
Yes.
And then I did say, my answer for the very same question that you are saying that I
yes.
did not give an answer.
Yes,
I
sir.
said my answer for
Yes,
that
sir.
system is 1, 0, 0, 1 in the first row. In the second row, I said I got 0, 1, 2, 2. That's what I said.
Yes, sir. So is that the only correct answer, or because I'm confused now, sir? Because if the other one says we solve differently and then you give us an answer, so which one is correct between? You see, that's what is confusing me.
Maza,
Yes, sir.
have you got a textbook?
Yes, sir. The linear algebra textbook. It's with me, sir.
Yes. Thank you. Let me request you to go to look for the definition of a reduced row echelon form.
Oh, okay, so I will look for it, sir.
In other words, what I'm requesting you to do is this. They will say to you, this is the system of equations. Then we take this system of equations, we write it in matrix form.
Okay.
Then they will say, we will solve it. We'll solve this matrix until it is in this form. Then when it is in this form, it is when then that will be saying that system is in reduced row echelon form.
Okay, now I hear you say, yeah. Okay. No,
Are you
say
sure?
I understand, say now. Yes. So actually the process is the reduce the colon form. It's the process of solving.
Hmm? Yes.
Oh,
Mhm.
okay.
These
Okay.
ones, the ones that I've just given to you, I've just given you now, are
Yes.
simple and straightforward. They are
Oh,
just not that active.
yes, yes. Okay. So no, now I understand 100%.
Okay. Are you sure?
I'm 100%.
Okay, Musa, here is a matrix for me. In the first row, please
Yes.
write 0, 1, 3.
0, 1, 3.
That's the first row, ne?
Yes, sir.
In the second row, please write 1, 2, 4.
1, 2, 4.
Not only Musa alone, all of us. Let's write this matrix in reduced row echelon form.
Okay, so I think I'm done.
Are you sure?
I think so, sir. Yes. I just swapped, say, 1 and 2, the rows. Then I have 1 there, then I have 0 there on the second row. Then I think it's done.
What have you got in the first row?
It's 1, 2, 4. Second row is 0, 1, 3.
That's not what I'm looking for. Obvious? You are listening?
Yes, I just got the answer.
Okay, what did you get, my brother?
I got first row, I got 1, 0, minus 2. The second row, I got 0, 1, and 3.
Thank you, brother. That's what I was looking for. Please tell them again, obvious.
Okay, first row, I got 1, 0, minus 2. Then the second row, I got 0, 1, 3.
Thank you.
For understanding sake, sir, can we have maybe at least one matrix with maybe 3 rows and then let us leave it in row echelon form, then we can double check it tomorrow if we all got the concept or something.
That's MAT also, ne?
Yes, sir.
Okay. Please go and digest what we did today. I've got 2 more exercises to test your understanding tomorrow.
Okay, sir.
Yes. Just double check that you did understand what we went through. So tomorrow we'll start with these 2 exercises before we continue. Is that okay?
Aye, that's fair, Minir, that's fair.
Okay. Thank you. Have a good one.